Why are humans locked inside the solar system by just two cosmic walls? Even more strangely, when Voyager 1 looked back at Earth from 6.4 billion kilometers away, the photos showed almost complete darkness, while from Earth, we see countless stars. Is this all just an illusion? Or is something preventing us from discovering the secrets of the universe? As early as 1950, Dutch astronomer Jan Oort discovered strange patterns while studying comet orbits and periods. He suggested that long-period comets may originate from a distant region outside the solar system, later named the Oort cloud. Although its existence can be indirectly inferred from comet trajectories and aphelion distributions, the Oort cloud is too far to be directly observed. To uncover the truth, nations have invested heavily in unmanned probes, seeking the secrets behind the twinkling stars. Yet, on the cosmic scale, human probes are almost powerless. Even the solar system, just 2 light-years across, cannot be easily escaped. Still, there were unexpected discoveries. In January 2003, Pioneer 10, stable for nearly 30 years, encountered strong electromagnetic radiation and sent back strange signals before losing contact. Voyager 1 and 2 experienced similar unknown interferences. Analysis revealed a terrifying fact. Our solar system is enveloped by a mysterious force, which seems to protect Earth, while simultaneously restricting human activity. This force resides in the heliopause, or the boundary of the solar sphere, composed of the midwave layer and a nearly spherical diffuse structure. It accumulates vast solar winds, forming a scorching hydrogen wall about 2 billion kilometers thick, with temperatures around 50,000 degrees Celsius. Voyager survived this region because the particle density is low, and without air molecules, large-scale conduction cannot occur. In other words, the heliopause protects the solar system from interstellar radiation but also acts as a firewall, limiting human activity. Scientists predict that if the Oort cloud exists beyond the heliopause, its width may exceed 2 light-years, meaning Voyager 1 would need 30,000 years to traverse it. Simulated models show the Oort cloud as a massive spherical structure wrapping the solar system like cosmic shackles, confining human activity. While the existence of the Oort cloud remains unconfirmed, if the Earth prison paradox is true, the dazzling Milky Way we see might be nothing but a virtual projection cast by this giant sphere. Perhaps physics itself is an illusion, and all astronomical observations and scientific evidence are deliberately designed under cosmic rules. So, if the Oort cloud didn't exist, what would the universe we observe really look like? In the universe, there are 5 extremely dangerous events, each of which could instantly annihilate life on Earth. Their power is almost unimaginable. Fifth, cosmic rays. Cosmic rays are high-energy particle streams dispersed throughout space. When matter falls into a supermassive black hole, it usually forms an accretion disk, and the intense rotation and friction within can heat the matter to billions of degrees Celsius. Some of this matter is then ejected along the black hole's magnetic poles at near-light speed, forming extremely powerful particle jets. If humans were struck by them, the DNA in our cells would be instantly destroyed. Fortunately, our solar system is shielded by the heliosphere, a massive bubble formed by the solar wind, which blocks and deflects most cosmic rays, preventing them from directly striking Earth. Fourth, asteroid impacts. The number of asteroids in the universe is incalculable. Within our solar system alone, humans have identified around 1.27 million asteroids, and almost every planet has experienced impacts. About 65 million years ago, a roughly 10-kilometer asteroid struck Earth, leading to the extinction of the dinosaurs. Jupiter's gravity protects Earth to some extent, reducing the probability of impact. Yet scientific calculations suggest that Earth could experience a similar-scale asteroid strike once every 100 million years. When will the next one occur, and will humanity be ready? Third, superflares. Superflares are among the most violent stellar eruptions. Unlike the relatively stable Sun, magnetically unstable stars can release energy far exceeding that of normal solar flares. Any planets in the affected system would be bombarded by intense particle streams and radiation. For Earth-like planets, such superflares could instantly strip away the atmosphere, exposing all life to deadly cosmic radiation, leaving the planet a lifeless wasteland. Second, supernova explosions. Supernova explosions are extremely dangerous cosmic events, constantly occurring throughout the universe. When a supermassive star burns out, it explodes violently. Planets within 50 light-years may be destroyed, and the resulting gamma-ray bursts could instantly obliterate life along their path. Archaeologists believe the Ordovician mass extinction, 440 million years ago, may have been caused by such a gamma-ray burst hitting Earth. Even more terrifying, many old, massive stars still lurk near Earth. Should one explode, the sky might reveal a double sun, signaling an imminent apocalypse. First, microblack holes. Microblack holes are the universe's stealthiest and most deadly devourers. They can consume anything, including light. The closest known black hole is 1,600 light-years away, relatively safe. However, theory suggests that in the early universe, black holes with a Schwarzschild radius as small as 1 millimeter may have existed, slowly consuming nearby matter. Although none have been detected so far, their potential existence cannot be ruled out. If a micro-black hole were to enter the solar system someday, humanity would face an unprecedented survival crisis. These events remind us that the universe is not only mysterious, but also harbors forces capable of instantaneously overturning life itself. Humanity is small and fragile within the vast cosmos, and our perceived safety is only a temporary illusion. How long is a light year, and what is the limit of human reach? The speed of light is currently the fastest known speed in the universe, traveling about 300,000 kilometers per second, enough to circle the Earth 7 times in 1 second. A light year is the distance light travels in a vacuum in 1 year, roughly an astonishing 9 trillion kilometers. So, how long would it take us to traverse a light year? 10.44 meters per second. This is the speed of the fastest human, Usain Bolt, who set the 100-meter world record at 9.58 seconds in 2009. At this speed, it would take approximately 28.7 million years to travel a light year. 33 meters per second. A fast car would take about 9.08 million years. 167 meters per second. The world's fastest maglev train would need 1.8 million years. 340 meters per second. This is the speed of sound at standard atmospheric pressure, also the speed at which a fighter jet breaks the sound barrier. At this speed, traveling a light year would take roughly 880,000 years. 3,335 meters per second. The fastest aircraft, NASA's unmanned X-43A, once reached Mach 9.8. Even so, flying a light year would take 90,000 years. 7,660 meters per second. The International Space Station's orbital speed would require about 39,000 years to cover a light year. 195 kilometers per second. The Parker Solar Probe, the fastest human-made object ever, reached this speed using a gravitational slingshot around Venus. This is only 0.065% of the speed of light, meaning it would still take 1,537 years to cross a light year. Clearly, a light year is an incomprehensibly vast distance for humanity. In fact, our solar system is enveloped by the Oort cloud, a vast sphere with a radius of roughly 1 light year, commonly referred to as the edge of the solar system. Only by passing through the Oort cloud can we truly leave the solar system. Even Voyager 1, the farthest human-made object, would take roughly 17,000 years to do so. Considering the observable universe spans approximately 93 billion light-years in diameter, and the human lifespan is only about a century, it is likely that we will never escape even the 1 light-year radius of our own solar system. This shows just how minuscule humanity is in the vast universe. Why does all life eventually end in death? It's a question we all think we understand, but few of us ever truly think through. It's not just life. Earth itself, and even the entire universe, are all living toward death. From the moment of the Big Bang, 13.8 billion years ago, the ending was already written. No one can change it. Legend says that 500 million years ago, somewhere in the distant M742 star system, a conscious being once asked its captain, "What is the ultimate truth of the universe?" The captain replied with just one word: entropy. So what is entropy? It's a concept that's incredibly powerful, yet so hard to fully grasp. Back in the early 19th century, physicists discovered that the world runs on energy, and that energy is conserved. It can't just appear out of nowhere, and it never truly disappears. But no matter how hard they tried, they could never make energy convert without losing a bit of it along the way. They tested countless methods, yet they could never reach 100% efficiency. So, the part of energy that was lost, energy that can't be used again, was named entropy. Later, this idea was summed up in the second law of thermodynamics. Every energy transformation increases entropy. In other words, a perpetual motion machine is impossible. Put simply, entropy measures disorder. Left alone, everything naturally drifts toward chaos. Why does a car break down faster if you don't drive it? Why does an untended house get dirtier and dirtier? Why do beautiful things never last? Fleeting clouds, fragile glass. Ancient wisdom told us long ago, nothing good lasts forever. Because keeping order demands fresh energy. The moment that energy stops coming in, order collapses. Life works the same way. The moment a living thing is born, its entropy starts to rise, bit by bit. Every bite you eat, every sip of water, that's new energy fighting back against the tide of entropy. This battle never really stops. All you can do is slow it down, but you can never stop it completely. When entropy hits a certain point, life ends. The only thing we can control is how fast or slow we get there. Human civilization is no different. From the moment our ancestors first tamed fire, to today's high-speed technological world. On the surface, we're advancing, getting more civilized. But from an entropy point of view, we're just finding new ways to hold back chaos. Renewable energy, cutting-edge inventions, they bring us stability and growth. But behind that order hides new disorder, garbage pollution, global warming, species extinction. To keep one corner of our world orderly, we're just shifting entropy somewhere else. Physicists remind us, entropy can never be erased entirely. From the moment we discovered entropy, we knew immortality is a myth. Everything, in the end, falls to chaos. A mayfly lives only 2 days. A turtle can live for centuries. The sun itself burns for billions of years. 100 years is just a blink to the universe, yet for us, it's a lifetime. According to the law of entropy, one day even the universe will meet its end. So what force truly controls entropy? What lies beyond the edge of the universe? Maybe that's an answer we'll never have. If you're fascinated by the mysteries of the universe, don't forget to like and subscribe. See you in the next video.